Hi everyone, my name is Deepak Kohli and I'm a supervisor at Red Hat, uh, title-wise supervisor. What I do is I manage the OpenJDK group over at Red Hat. So this talk is about, well, as the title says, OpenJDK plus open source enhancements. The reason I wanted to have this talk is because I see a lot of talk happening about OpenJDK, but I feel that one of the reasons why OpenJDK adoption is not as, or one of the things that affects OpenJDK adoption is the fact that it does not have everything that the proprietary JDK is giving. Now, that doesn't necessarily mean the Oracle JDK, it also includes what the IBM proprietary JDK has. So this talk is to shed light on what we as in like Red Hat and the community as a whole are doing to sort of bridge that gap to make OpenJDK a more complete distribution that looks very familiar to what the proprietary JDKs provide. This talk is not specifically about what Red Hat does, it's about what the community does. It's not specifically about IcedTea, it also includes things like projects that are hosted on openjdk.java.net. It's just about projects in general that are outside of OpenJDK, but that help complete OpenJDK to make it a full distribution like the proprietary Java proprietary JDKs. So this is just the usual slide I have. There's an index on the left side if you want to follow it. If you're falling asleep, you know how long you have to stay here. And okay, so let's take a look at, this is a very simplistic picture of the JDK. But if you take a look at it, generally what you have in your JDK is you have your hotspot virtual machine, which has the interpreter in the JIT. You have your tools like JavaC, JavaDoc, etc. And you have your class libraries. Looking at what the proprietary JDK gives, in this case, I am referring to the Oracle JDK because you can see that on the right side in the red there that says 5%. So if you look at the mix that Oracle JDK has, about 95% of the code base is open, 5% of it is closed, based on what I've heard. I don't know how true that is. And Oracle JDK also, if you download it from the web, it gives you deployment tools such as you get the Java WS and the plugin. And there are also serviceability tools for developers. They're not part of the standard JDK, but they're sort of expected by developers who want to profile and monitor and instrument their applications. So that's the view of what a JDK is. And it differs slightly between developers and users. For developers, some developers care about deployment tools, but that's only if they're writing applets or Java website applications. For the most part, developers care about the virtual machine, the tools like JavaC and JavaDoc, the class libraries that are there, and serviceability tools. Looking at it from home users' perspective, home users don't care about serviceability tools. They don't write applications. What they care about are deployment tools because a lot of users view Java through their web browser, through the plugin. Home users don't strictly care about the Java virtual machine, but it's what's really running their applications underneath. And the class libraries, of course, support that. Home users don't care so much about tools because, again, they're not going to be writing applications. They don't need the compiler and JavaDoc, which is why the JRE does not contain those things either. So let's look at each of those items in part, items that are not available in OpenJDK. First of all, there is the closed source code. What's in there is unknown because, of course, it's closed source code. Some of the things are known, such as, for example, the ARM JIT that's part of the Oracle JDK is closed. It's not going to be open anytime soon. There are no plans for it. Looking at deployment tools, there's a plugin, and there's WebStart. These are a part of the IBM JDK has this, and so does the Oracle JDK. Looking at serviceability tools, Oracle, the JRocket JDK has JRocket Mission Control. IBM has Health Center. I'm not sure what the counterpart for Hotspot is, but I'm sure there is one. But this is lacking in the open source community. There are also things that are, for example, platforms that are not in OpenJDK. Currently, OpenJDK supports your Intel 32-bit, EMT64, and Spark. But there's a whole host of other platforms that are not supported by OpenJDK that certain other JDKs do. For example, the Oracle JDK supports ARM. IBM JDK supports PPC, PPC64, S390, S390X. So there's basically a lot of them. These are just some of them. Titanium, probably not as used as, anymore, but PowerPC is used by a lot by businesses. Systemz is used by a lot of businesses. ARM is what businesses are going to use in the future, the way things are going right now. There's a whole lot of other ones as well. So we want to complete OpenJDK. We want to add these pieces that are missing, and we want to complete it to make it compete with proprietary JDKs, but through open source. Right now you have OpenJDK, but OpenJDK is not set up, especially at the very beginning when when the code was put up on he.java.net. There were a lot of barriers to entry, and certain things were needed to make it possible to add these things to OpenJDK. So what are those things? Well, first of all, you need a bug tracking system. Now, I'm not going to go into the details of how a bug tracking system should be provided, because that horse has been beaten to that in other meetings all day. But it's needed, right? It's missing, and you can't write high-quality, good software, especially large projects, without a proper bug tracking system. So it's needed. You need a system to patch things. OpenJDK, initially, the barrier to entry was extremely high. Adding a patch and getting a patch into OpenJDK was non-trivial. Which means that if someone had a performance patch, if someone had a security patch that Oracle didn't like, or if someone had some kind of bug fix patch that Oracle didn't like, they had no real way to maintain it other than maybe inside their specific spec files. And this was, from a community perspective, the community might have accepted it, but Oracle might not have liked it, so it didn't end up going in. This process, I should point out, has improved very significantly now. The barrier to entry has gone down significantly. There are still issues that remain. A lot of them were brought up at the governing board meeting this afternoon, and hopefully they will get resolved shortly. You also need build infrastructure. Currently, the OpenJDK build system is not the greatest in the world. It's very rigid. It's not very configurable. And when it comes to adding things, especially like other platform support, like being able to plug in another virtual machine like JamVM or Cacao or something like that, it is extremely difficult. Again, with this one as well, the build infra project is looking very, very promising, and I'm hoping that a lot of these problems will be solved by build infra. So let's take a look at what the solutions are for these problems that are currently being used by the community. First of all, for IcedTea, for bug system, we have icedtea.classpath.org/bugzilla. This is where bugs currently go that are related to the deployment tools that we use, to the serviceability tools, the deployment tools that we're working on, the serviceability tools that we're working on, the zero stuff, the ARM stuff. That's our Bugzilla. It's working, we control it, and it works well. Of course, this is now. In the future, of course, the hope is that this can all be moved into a proper openjdk.java.net domain when the Jira is up and working. Next step is, what is going on? Okay, our next step is being able to add patches. For IcedTea-6, we had a patches directory where we kept all of these patches that I referred to earlier, which may have been bug fixes, or actually there are no, I shouldn't say security fixes, because security fixes are done by Oracle quite regularly and quite well, but more like bug fixes or performance enhancements that don't necessarily apply to, let's say, Oracle customers. Back in the days of 6, it was extremely hard to get patches in, so they resided in the patches directory. With OpenJDK 7, we still have a patches directory in the IcedTea-7 directory, but it's extremely small. A majority of our patches are now actually in a hybrid forest, which is pulled from the OpenJDK upstream forest, and then we patch it. The reason why it works in 7 and not in 6 is because the patch count is significantly lower in 7. We worked on getting a lot of those patches upstream as much as possible. And in fact, going from 7 to 8, we are working hard on getting all of the patches out of 7 and putting them all into upstream OpenJDK as the barriers to entry go down. So the hope is that in the future, everything will be upstream on OpenJDK, and that's what distributions will be able to pull and build from. They won't need the surrounding infrastructure of IcedTea, which actually brings me to the next part. IcedTea does provide one other important thing. It provides support for things like being able to hook in system libraries, being able to use multiple virtual machines like JamVM and Cacao. And for those ones, I actually can't think of a solution. So we'll have to, maybe next year we'll have something for that. Hopefully Build Infra will be able to solve some of this. So this is the foundation. You need a proper bug system. You need a system where patches can be stored, patches that don't go into OpenJDK. And you need a highly configurable build system so that you can do things like plug in different VMs for different architectures. So the next step, you use all of these tools that we currently have, and we start filling in the gaps. So let's deal with them one at a time. The first is the closed part. Well, whatever is closed in terms of performance, we can't really fix it because we don't know what is closed. But things like, for example, the ARM port is closed. That we can work on through other means. So these are the platforms that we would like to support. Just some of the platforms, actually, we would like to support a lot more. The first step towards that is being able to provide an interpreter. I should have removed that middle line. Sorry, Andrew. So Zero is a C++ based interpreter. Currently, the interpreters that are used in OpenJDK have assembly in them, which means that it's non-trivial to port them to other architectures. But Zero is written in pure C++, which means that it is quite easy to actually port it to other architectures. Basically, if you have GCC on an architecture, you can build Zero. If you can build Zero, you have interpreter support, and you can run all Java code that's out there. And with Zero, we have gotten PPC to pass TCK, and it's not that hard to get it passing on other platforms either. It's obviously, it's an interpreter, it's not a JIT, so it's not going to give great performance, but it gives passable performance. And there are other things that we can add on top of it. For example, things like Shark, which is an LLVM-based JIT, which will give even better performance in the future. Next is the ARM JIT. A lot of this work has been done by Andrew Haley, who works for Red Hat, and it's based on an old port that was done by Ed Neville for the Thumb2 JIT, but Andrew recently, for the past many months actually, has been working on it nonstop. He's gotten it into a great state, works with OpenJDK, and passes TCK6 completely. TCK7 doesn't fully pass yet, but that's because of there are some things that are missing in Zero related to JSR 292, which was quite a big change. So we're hoping that by November we'll have all of these issues resolved and we'll have a full TCK7 pass as well. The ARM JIT that we have is a C1 type JIT, so it doesn't do C2 type kind of high-level optimizations. It does C1 level. The performance is actually quite good, especially compared to pure Zero, which is an interpreter only. It's handwritten assembly interpreter, so like I said, works fast because it's in assembly, as opposed to like pure state machine-like interpretation that Zero does. It's been shipped in Fedora since Fedora 17. Because we have full TCK pass, we can ship it. It works fairly well. We have a lot of stuff building in Fedora with this ARM JIT, and it works. It builds fine. It runs fine as well. The last line there is interesting because I just added that a while ago, actually. We are also working on an ARM64 JIT. To our knowledge, this is the only ARM64 JIT in existence. Our plan is to eventually make this open source as well, but there are NDAs and things, so it can't be done just yet. But this will be the first ARM JIT, and it will be fully open source. The first ARM64 JIT. And again, a lot of work being done by Andrew Haley, and also helping him is Andrew Din, who works for Red Hat as well. So other parts outside of OpenJDK. So that takes care of the closed source part. We also have the deployment tools, which is plugin and WebStart. For that, we have a project called IcedTea-Web, which provides a plugin, provides WebStart, and provides a configuration tool to be able to control the configuration for those two tools. So the last part, the settings tool, is very similar to the control panel tool that you'll find in the Oracle JDK, for instance. The plugin is very featureful. It has feature parity with the Oracle plugin. It has full Live Connect support. It works with multiple browsers. We tested off this list here. I know we tested with Firefox, with Chrome. I've tried it with Midori, and we also run tests on Epiphany, and they all work great. So WebKit and Gecko-based browsers both work well. The other interesting thing is that it works on architectures that wherever Zero works. The plugin has nothing assembly specific. This is interesting because if you download the ARM JDK from Oracle, it does not have the plugin or WebStart. whereas IcedTea-Web will work on ARM and WebStart. I actually posted that on my blog a few months ago, a working, fully functional plugin on ARM. First one I've seen. WebStart as well. It's almost feature parity with Oracle. There are a few things missing that we know that we're working on. We hope to get them done soon. Has full headless support, and again, the only website that works on a whole range of architectures where proprietary JDKs do not currently work. And IT Web Settings, which is our deployment settings configuration tool. This tool provides everything that Control Panel does, and in the future we want it to provide more than what Control Panel does. Right now it provides full certificate management, it provides proxy configuration, cache management, and security configuration. We also wanted to provide more fine-grained security configuration for cases where you may want to trust an applet only with certain things. For example, like if you're using Illuminate or Blackboard or one of those things, you may trust the vendor to a certain extent to do certain things, but not everything. You may not want them to access your file system, for example. So you want more granular permissions, even for trusted certificates, and that's what we intend to provide eventually as well. So that's IcedTea-Web. It has the browser plugin, WebStart, and the settings tool. The idea of IcedTea-Web, right now it exists under the IcedTea umbrella, but we want it to go into OpenJDK proper. There are steps that need to be taken before this happens. Andrew had a great idea the other day when I was talking, which is why don't we propose this as a JEP and have it as a separate project under the OpenJDK umbrella, which is one step closer. So that's what we're going to work towards. There are a few things that need to be worked on design-wise, which is the reason why we haven't done this right now. There is a patch sitting on the mailing list right now for refactoring a large chunk of the code. So that takes care of about 50% of the refactoring that we want to do. The other 50% is related to class loading. Once these refactorings are done, we intend to propose it as a JEP, put it under the OpenJDK umbrella, and then when it's complete and when we have consensus from everyone, including OpenJDK members, merge it into OpenJDK, because this is one of those things that should exist in the OpenJDK tree itself and not outside of it as a separate tool. The other part that's outside of JDK is serviceability tools. Right now, as I mentioned earlier, Oracle has JRocket Mission Control. IBM has its Health Center. OpenJDK has nothing right now, which is why we're working on that. For those of you that attend the tool, Roman and Mario who are here are two of the primary developers for a tool called Thermostat that we're working on. So what does Thermostat provide? It provides you the ability to profile, instrument, and what was it that there are four things that I always say: profile, instrument, manage, and monitor. That's the one. Thank you. Those four things at an application level for your application. But you may want to go deeper. You may want to see what the JVM is doing. And Thermostat provides that as well. You can dig deeper into the JVM, see when garbage collection happens, and all other kinds of garbage collected statistics. You may want to go one level lower. You may want to see what's happening at the lower level libraries. Maybe see how long a malloc call takes for allocating a gigabyte of space or something. You can do that as well. Or you may be an expert on the Linux kernel. You may want to see things related to, let's say, the scheduler. For those of you who are familiar with the OAuth1 schedule, for example, it punishes CPU-bound tasks, rewards IO-bound tasks. So depending on how your application is behaving, you may want to monitor that, see how the kernel is adjusting priorities, and maybe manage your application threads internally accordingly to make it even more efficient. So it provides that. This is at the one machine level. Another really nice thing about Thermostat is that it scales. It can actually go to an arbitrary number of of machines. So you can have a cluster of one machine, cluster of two machines. You can have a cluster of 200 machines, and Thermostat can monitor all of them simultaneously and give you data from a single interface. And we're working on a lot of interfaces for it as well. Right now we have a swing interface and we have a command line interface, which makes scriptability really easy. Our intention is to also provide an Eclipse plugin, which we're actually working on right now as well, which will allow you to profile, monitor, instrument, and the other fourth thing from Eclipse itself. We also are working on a web client, which will allow you to do it from the web. And another interesting thing that Roman and Mario mentioned is that because the Thermostat agent and the agent that writes to the database are separated, and you can write an arbitrary kind of interface for it. We can also write interfaces for mobile phones, for example, like iOS or Android or something, making monitoring really easy. Thermostat, the architecture is extremely pluggable. It's a lot like Visual VM if you've used it, where you can add in any kind of plugin you want to monitor any kind of data and have that behavior show up in Thermostat. So I'm going to show a quick demo, but here's what the screen more or less looks like. You can do, I can't see on this, I'll just show it to you in the demo. But that's what the Swing client looks like right now. So, demo for Thermostat. This is going to be a very short one. I hope a lot of you attended Mario and Roman's presentation. They did a much better demo. Oh, I hope not. Okay, excellent. So step one works, it starts up. So you can see here that I'm monitoring my machine. Espresso is just my machine name. I'm monitoring, you can see the various processes that are running on my system right now. There's Thermostat itself, the service is the agent. You can see here from the command line that was running there. You can see that applet.plugin main is running. This is the IcedTea plugin, so I probably have an instance of the plugin running somewhere that I was working with earlier. And the other is the GUI client itself. So you can see that the agent and the client are separate. They start as separate Java processes. So you can have like 50 agents running on 50 machines, and you can have a single client running on a monitoring machine and monitor all of those from that nice single interface. So let's, I just wrote a couple of very simple applications. So this is just called, it's a short-term memory demo. All it does is it really allocates memory and then it deallocates it. So you can see the hidden space grow and then shrink, grow and then shrink. You can see the S0 space eventually grow and shrink as it gets written down to S1. Eventually S1 shrinks and it gets written to old. I won't keep this running for long, but if it runs long enough, you'll see that eventually things get deleted from the old generation and it goes down. The nice thing about this is that you can see, well, you can see how long the garbage collector, how the garbage collector runs as well. So I won't go into details of, this demo was originally written for another conference that I gave a talk at. But the idea of the program is that it creates a lot of objects very rapidly and then lets them all go. But it doesn't let them go before things get pushed down to the old generation. And in the demo, the way it's running right now is that it starts with a small, S0 or a small ratio of these various survivor spaces. So what I was trying to show with the demo was that a lot of these garbage collector pauses can be almost eliminated if you simply change the ratios. Like if you're seeing this kind of profile in your application where things get pushed down each generation and eventually the generation just collapses, you can adjust the ratios to make it so that it never gets pushed down to those generations. So garbage collection doesn't really need to happen on the old generation. And the other app is to show, so I'm just going to stop this app. This is to show what I think is very, it looks very pretty, which is the thread monitoring that Mario added. He was working on it very hard before Java 1, I know. So thread monitoring is not enabled by default because it's a very expensive operation. And one of the things we want to do with Thermostat is keep the overhead as low as possible. Right now, I believe Mario ran a spec test on it, and we found it's about anywhere between 1% to 3%. And we want to keep it at that level as much as possible, which is why we don't enable things that we know are going to be expensive. So for example, if you look at heap memory over here, which is over here, it doesn't do real-time heap monitoring because that's a very expensive operation. What you can do is you can say dump the heap. This is, as Mario mentioned earlier, stop the world operation. So it's expensive, which is why we don't do it all the time. But if you want to, at some point, if your application is stuck or if you see a weird memory profile, you can dump the heap, and then you can see this is a simple histogram of what kind of objects are allocated. You can sort it by size, you can sort it by instances, and you can also search for objects and go down all the way to the roots and look at the referrers or the references to the object, or what the object refers to, rather. But anyways, on this one, what I wanted to show you was, so this is a very simple application. What it does is it has two threads. Only one thread can be active at a time while the other thread stops. So you can see things like this time statistic, which is, can't really read from here. Well, this is not a good thing to show because this projector can't really show the colors that that are over there. So maybe you guys should use more contrasting colors. It shows up fine over here if I pull it onto the screen. So normally it's supposed to be or not. Never mind. Yeah, the demo gods are not being nice. So there's something wrong here. It should have normally shown you while thread 1 stops, thread 1 is, while thread 2 stops, thread 1 is going, while thread 1 stops, thread 2 is going, and so on and so forth. I can see it doing on command line here as it prints it, but I don't know why it's not showing me that. Anyways, so that's thermostat. And of course, this is where your machine is. All JVMs on your machine show up here. You can add multiple machines if you have a cluster of them, and you can monitor them all at once. So let me go back to my presentation here. So that's what I meant when I said we need to complete the JDK to make it more appealing to sort of home users. And these are the projects that are currently being worked on by the community. There's the IcedTea project, which provides sort of the build infrastructure and the patch management infrastructure. We have IcedTea-Web, which provides deployment tools. We have the ARM JIT, which provides a JIT for ARM32 and also ARM64 coming soon. We have Zero, which provides support for Java on any arbitrary architecture as long as you have GCC. It works quite well. And we have Thermostat, which fills in the gap of serviceability tools. And these are really, these are good. In the future, there may even be more projects, which I was actually hoping for audience participation on this part. Are there any projects that anyone is aware of or anyone is working on that you guys think make a better fit for JDK that should exist on the OpenJDK.net site? Okay. Well, for the most part, these fill in all of the gaps that I had said in my original diagram over there. They fill in the closed source gap, which is they provide the ARM JIT. They fill in the deployment tools gap via IcedTea, and they fill in the serviceability tools gap via Thermostat. The hope is that eventually IcedTea will not be needed. Currently, of course, that's impossible because there are barriers to entry. You can't even commit to hotspot. It's just not possible right now. Eventually, though, it would be really nice, and that's our goal as well, to work with OpenJDK upstream to get rid of it. Same with IcedTea-Web as well. There's no reason why it should exist as a separate project. It would be best if it gets folded into OpenJDK itself. Thermostat will continue to remain a separate project because serviceability tools don't really belong in the JDK itself, and that's fine, but they are one step towards getting a more complete JDK that users and developers are used to. And of course, Zero and ARM JIT as well. Eventually, we want them folded into OpenJDK proper so that everyone can benefit from it without having to go to the specific distribution or without having to go through IcedTea and whatnot. And that's it, really. Are there any questions? Yeah. So AIX HPUX, no. There is effort going on currently to get PPC in, PPC JIT in, and actually I believe Voka is right here. He's one of the people working on it. And I know the BSD guys are building it as well, so it does work on certain operating systems outside of what are mainstream.
What's the people who have people start really using OpenJDK in the production system, or where we are?
OpenJDK is used in production. We have customers who are using it in production systems. It works quite well. I mean, the shared code the code that's closed source between Hotspot and OpenJDK are not bug fixes. They're sometimes related to things that Oracle customers specifically need. They may be related to serviceability tools, but not necessarily performance. So as far as production use of OpenJDK goes, the stability, I would say, is pretty much on par with what the proprietary JDK offers. So yeah, I would say it's ready for production use.
What's the motivation? You can download Oracle JDK for free as well, right?
Right.
What is the motivation for commercial usage of OpenJDK?
Bug fixes. If you as a customer have a bug fix with open source, that's one of the biggest draws of open source. First of all, the code is open. If tomorrow Oracle decides to stop distributing the proprietary JDK and you've built your entire stack on it, you're out of luck, essentially. You have no choice. If they make it paid, you have to pay them whatever they charge. Whereas with an open source version, the code is open. It's under the GPL license, so even if they decide to take it offline, you can simply fork it. But the bigger power is really just the fact that it's open. You have a lot more eyes on it, essentially. It's open code. It's code that you can see, unlike the proprietary JDK, which is closed code. With open code, you can do bug fixes. If your developer finds a bug in the JVM based on your application, you have to go through Oracle. You have to wait for them to fix it and hope that they fix it. Whereas with OpenJDK, you can apply the fix yourself, even if OpenJDK community refuses to take the fix. So it's the general closed source versus open source advantage. It's fully open. You can do your own bug fixes, and you don't have to worry about if the vendor stops distributing it tomorrow. Yeah. Any other questions? True. So Andrew's saying that there are parts of that 5% that I mentioned earlier that do have open source equivalents, and that's true. The only thing is I don't know what the percentage is, because I know some parts of what... Oh, okay. Yeah, so it's probably even closer than 5%. Yeah. All right. Any other questions? Yeah.
So, do you plan to put the ARM code inside the project?
I will let Andrew Hilly answer that. You can come over here, Andrew.
Yeah. Thank you.
It's important to realize that ARM64 is only ARM in name. It is not in any way related to the 32-bit ARM architecture. It's a wholly new instruction set. It doesn't really share anything with the existing ARM code base, and it will be entirely done from scratch. And yeah, it'll definitely be an OpenJDK project. I wouldn't want to do it any other way. And it'll certainly be the first new port of OpenJDK done in public. It'll stay in IcedTea. It would be nice if it were developed further, but to be honest, I don't really have any interest in it. It's fine, it works, whatever. The future's definitely going to be 64-bit.
So I know with the 32-bit there's like C1, there's C1 and C2, whether you give us more or
Yes.
Does that still exist
In the 64-bit? I'm going to have that conversation in public, I think, on the mailing lists. At the moment, I simply don't know whether we want to write a C1 compiler for ARM64, because it's a separate job. I mean, there's no reason why the C1 and the C2 compiler couldn't be written entirely independently as separate tasks by different people. But I suppose you want C1 for fast startup, and I suppose there's a lot of talk about tiered compilation, so it might be advantageous to have C1 in order to do tiered compilation. I don't know. Maybe C1 would be advantageous as well because it'll be quicker to write, and we'll have something that we can ship more quickly. I really don't know. Volker, have you done both of C1 and C2 or just C2? Only C2, yeah. So you don't really know how much easier it is to do C2, C1 than C2? No. Okay. Well, I don't know either. I mean, yeah, it should be. I mean, you can tell we're kind of learning as we're going along here, but I'm hoping that we'll be able to get Oracle engineers involved to advise and help and cajole and all the rest of it, so we might get there a bit quicker.
All right, any other questions? Yep.
So the server side development, we rely on JDK, but also the app server support. Right? So what's the JBoss OpenJDK now?
So what do you mean by server support? You mean what does JBoss support?
Yeah, do JBoss support OpenJDK?
JBoss supports OpenJDK. That's distributed in RHEL, yes. And it supports the Oracle JDK as well. It supports everything that we distribute in RHEL. So that includes the IBM, Oracle, and OpenJDK. Yeah. All right, any other question? All right, thanks everyone.